Good afternoon, it's Charlie here. Just thought I'd do a video to look at sort of the ideas, the design ideas and some of the objectives for this next build. As I mentioned in the last video, what I want to do with this one is to build a monoband 80m radio, and what I think I would like to do is make it both SSB and CW, and I think, and we'll talk about that when we get to the transmitter part, sort of looking at least 20 watts plus. I think that's sort of where I want to be. So not QRP, but certainly not up into the 100 watts area where I sort of need some high voltage components. So that's sort of 20 watts plus, 20 to 50, anywhere around there would be quite nice. Quite keen to look at some of the lessons that came out of the previous radio, and essentially just to try and expand on those. I am going to use a 9 megs IF, and I'm going to use a couple of these commercial XF92A filters. I've got two of these exactly the same, so you might recall what I said I wanted to do in the last video is I'm going to have a separate receiver and a separate transmitter. They will share a common oscillator, again, which we'll talk about soon, but they're essentially going to be two separate systems, one for transmit and one for receive, obviously. I do want to look at some of the grounding on this one. I just want to make sure that I don't have any problems with ground loops and the like, and also sort of wanted to look at grounding from a signal ground versus DC ground for running the various amplifiers. So it's whatever, sort of a close look at that to make sure I'm not sort of introducing any unwanted noise. I am going to use, for both the transmitter and the receiver, SBL1s from Mini Circuit. I've got four of these, so I'll dedicate two for the transmit and two for the receive, which we'll look at shortly. I have actually ordered from China through AliExpress some ADE1s. They were at the same price as you would get from Mini Circuits if you were to order 20 plus. I would have ordered them from the US, but they were going to charge me US dollars, 141, to ship 20 of these very small devices to New Zealand. I'm not made of money, and money doesn't grow on trees here in New Zealand, so I'm not going to do it at this stage. I might look to get some of those sent to a hotel in a future visit. So I have looked at and found some AD1s online through China. Be very careful though, if you are using likes of AliExpress, you will often see a prefix -24 being advertised on that website. Now the -24, from all I can find out, suggests that it is not per the original data sheet for the AD1, but it's been modified to suit whatever the particular manufacturer had ordered. So that -24 signifies it's been modified. So who knows what the input and output impedance is? Who knows if it's still a plus 7 dBm mixer, or is it, it's 8, 9, 10, or is it less? You really don't know. So just a word of caution there, that if you are going to order these and it's got the -24, you don't really know what you're going to be getting. So at this stage I'm going to use the SBL1s, and if these ADE1s do turn up, then I'll look to probably either this build or the next build retrofit those in. Let's see how we go there. What I also want to do on this radio is I am going to start off by using the SI5351, which I've used in several previous builds. And what I do want to do once it's built is have a close look at birdies through the receive band. In the past it hasn't really worried me too much, but I have noticed that if you were to tune through a particular band, there would be the odd very sharp frequency where there's just a birdie coming through. It's not broadband in any way, shape or form. It's very, very highly selective, but you know, they are there. So what I'm thinking about doing is considering starting off by using the SI5351 and then potentially looking to use these AD9850. The downside of the AD9850 board here versus the SI5351 is this has only got one output, whereas the SI5351 has three: clock 0, clock 1 and clock 2. So which is quite nice, because for a single conversion superhet you can have, for example, clock 0 for your initial VFO, and then you can have clock 2 for your BFO. But if I go this way, then I have to have two of these, one for each. And if I'm yeah, and then they're not I2C for talking, so you need to have, I can't quite remember the exact, I have to go back and look at some of the previous projects where I've used these, but you know, you do have something like 6 odd pins that you have to then tie back to your microcontroller to talk to it. But this will output a synthesized, quite a nice synthesized analog square wave, a nice analog sine wave, as opposed to the SI5351, which is square. Again, I think I've talked on some previous videos about from the Solder Smoke blog site, there was an article there which talks about the use of square waves for mixers, and actually they're quite good. But I do want to have a look at birdies. Are they being caused by this? If I was to switch to this, would they disappear? So I need to do a bit of sort of thinking about that aspect. I am going to, for this particular build, again use discrete components. So I will be using the J310 combination again. So 2 cascoded J310s for the various amplifiers. But I do want to have a closer look at both the gate resistance, and also the source gate drain, the drain resistance there. Just sort of looking at using LT Spice, what is the ideal impedance to have being presented to the drain as well as the gate. So I just want to have a bit of more thought about that one. So I'll probably do a little bit more on LT Spice and just sort of see how that plays out and what the advantages and disadvantages are. I also want to have a probably a little bit more use of the CNC machine here and there, not for all the circuits, but you know, where it makes sense, I might look to, and certainly for the power amp, look to use the CNC machine sort of here and there. And as I just mentioned, LT Spice, definitely sort of using that as much as I possibly can before committing any of the components to the boards. In terms of the display, I've got a choice of sort of utilizing the same display we used for the last radio, or potentially reverting to a sort of a traditional 16 by 2, or even a 16 by 4 LCD display. I'm open to suggestions there. If, I'm going to certainly make any software that I use available, and if people would like to see some LCD software, i.e. these two, rather than what was that one? That was a 320 by 160. That's again 128 by 160 display. You know, I can use either or, so just let me know what you'd prefer there. I don't particularly mind. So that's sort of at a high level what I'm thinking about. In terms of the actual receiver side of the house, being 80 meters, the guidance from Solid State Design with Radio Amateur and the like suggests that there's really no need for an RF amplifier prior to the bandpass filter. So at this stage I'm going to do away with that, but still look to have that around 100 dB gain spread out across the circuit. So these will be probably in the region of you know, sort of 20 to 25 dB These are obviously a little bit of loss here, as well as the filters, and then I'll make up the difference in the power amp. In terms of this bandpass filter here, I am going to use again, I was toying with the idea of using varactors to tune that, but what I thought I might want to do, in fact what I am going to do, and I can always look at varactors down track, is I'm going to combine two of these bandpass filters using the one variable capacitor, because you have outputs on both sides. So this is floating, i.e. it's not earth, same with this side, whereas the middle is earth. So I'm sort of thinking about the feasibility of having these joined together. One side will be for the receive, and then the other side will be for the transmit. That way I don't have to have double of these trying to then peak the receive and peak the transmit. I only take one. And then I could look at tuning out any inaccuracies with winding the inductors by having a couple of little trim pots there, just to peak both sides for any one particular setting of the capacitor. So that's what I'm thinking. I'm going to give it a go. If it works, it works. If it doesn't, well, hey, that's what it's all about. It's all about experimenting and playing around. So that's that particular filter there. We talked about the mixers. I'm going to use the SBL ones, or if those ADE ones turn up in time and are the right type, potentially the ADE ones. Again, going to be using the Cascoder J310s we spoke about. The crystal filter will be this one here, with a 9 kilohertz, so again a 9 megs IF through there. Now for the amplification, or the IF amplification after the crystal filter, or the frequency selective device here, bandwidth, I'm going to not initially design in AGC. It'll be a manual AGC, just using a standard pot that will vary a DC voltage onto the gates to vary the overall gain of that IF amp, and then later on down track as a stretch goal, so to speak, I can then look at redesigning an IF amp to then feed back and do that automatically. At this stage of the game, and I have no problems with using manual controls. As you can see from most of my radios, there's buttons and knobs everywhere. That'll be manual first, and then we'll look to potentially throw in an AF amp in due course. Second mixer, or product detector I should say, will be again the SBL1 or the ADE1. The amplifier for this one, I think I might sort of go back to a simple, just for this build, a simple approach with a single stage 3904 feeding into an LM386. I don't want to run, per the spec sheet, the LM386 flat out, so we'll bring that gain back to maybe 5 times, maybe a bit higher, 10 times perhaps, and then we'll make up the difference to get up our overall gain for the receiver in that stage there. So we'll see how that plays out, but suffice to say, looking at a single stage BJT feeding into the LM386. We'll look to use that old meter again in due course, so once we get that AGC coming back through, then we can pick that off and drive the S meter. The other option is doing it down here at the AF, but that's not particularly good because it tends just to be the peaks that have been coming through on the S meter there. So that's what I'm sort of thinking in terms of the receiver, and then we mentioned before, as sort of an overall goal, once that's been built, I won't do the transmitter straight away. We can then sort of spend some time looking at noise, birdies, and whatever. So that's what I'm thinking about in regards to the receiver. The transmitter, so I think for the microphone this time I've got another junk box microphone here. I've got one which has got a 4-pin socket, and I've got another one which has got a 5mm stereo. So I think I might use that this particular time just to see how that goes. Sort of got those through an auction site, so we'll see how that sort of plays out. The mic amp will be a 3904, and then feeding into, again, exactly as we saw in the receiver, either SBL ones or an AD one. Now for the CW input, what I'm thinking there is, with that cascade arrangement for that first IF amp, I'm thinking about feeding in. So in the gate will come the normal SSB. Well, I should say actually, yeah, the SSB there, and then feed in through the gate. Say again, my apologies. The source, the CW. So that's what I'm sort of thinking there, and we'll see how that one plays out, and then we'll work out keying for that. Now, I was sort of thinking, the beauty of the SI5351 is it's got a third clock output. So my initial thoughts were, once the radio gets put into CW mode, have the microcontroller turn on that third output, and then look to heavily filter that to turn that sort of square wave into a sine wave, and then feed that into that IF amp to produce the CW. That'll probably need to go, once it's sort of, what I'm thinking is, the SI5351 output, heavily filter it, feed that into a buffer amp, and then have the buffer amp being switched through the Morse key to then output the CW into that amplifier there. That's what I'm thinking. If someone's got a better idea or thinks that's crazy, then please sing out. But like I say, this is all about experimenting and playing. The crystal filter will be the other, or that second crystal filter that we've got lying around, and then again into a second Cascode J310 amplifier there. At this stage I'm not going to make that variable, but it certainly can in due course, and maybe perhaps we'll see detect that output power, look at the reverse VSWR or the reverse SWR, and then maybe have that being fed back through a DC amplifier to drive that. We'll see, but at the moment it's going to be a fixed gain on that one. Once it's up to our desired transmit frequency, which will be in the 80 m band, what I want to do for the power amplifier is I want to reverse engineer this. This is it's off an old Codan radio. According to the specs, it was supposed to be a 100 meg, say again 100 watt radio. It's got some Motorola MRF 421s, which are 100 watt devices, and then some MRF 220s for the driver stage. And they're supposedly rated from the spec sheet at 40 watts. So I am looking to, and what my plan is to do is to slowly pull this apart, take off all the excess components, and then just sort of have a close look at the transformers coming out of the pre-driver stage here. I know this is probably the wrong terminology, but we'll call this the pre-driver stage, the driver, and then the power stage there. So I want to look at what's going on with that particular transformer there in terms of turns ratios, that one there coupling between the two stages, and then this balun here, or this transformer, how that's been particularly wired up, and see if I can get some lessons learned out of there for future builds. And then what I'll do, once I've got these components desoldered and off the board, I'll then look to use that CNC machine again to make another replacement board, much more simplified, with just those devices, the transformers, and then any other biasing devices or stages. So that's the plan, is to have a good look at this, understand what's going on here, and then endeavour to sort of simplify it. So the plan goes. I probably won't utilise this, but this is detecting both the forward and the reverse SWR, which is then fed back into the automatic level control, which is back over here through that device. So that I'm not going to worry about at this stage. I'll just, like I say, concentrate on this part here, and we'll see what we can squeeze out of it. Yep. What we'll also do, we'll use this again and just look to create a simple circuit to detect that transmit power, and then we'll feed it back into one of these scales here. And I suspect that the power out one will be the best one there, 5, 10, 15, 40, up to, even though it says 80%, I don't want to get up there, but maybe in watts, so I'll see what happens here. If there's anything like the last build, that amplifier went pretty well, and I was getting well and truly over 30 watts on the 80m band, so we'll see what happens there. The other things I was going to mention, the other beauty of pulling this one apart is supposedly these will be matched devices, which will be quite good, so we'll see how that plays out. So I think that's probably all I was going to mention in terms of what I want to do with this radio. How long have I been going for? Sort of 20 minutes. I probably don't want to go on much longer than this. But I do want to at some stage look at some future builds. I'm probably quite keen to do another tramping radio, or another hiking radio, tramping, hiking, bushwalking, whatever you want to call it, but make that significantly smaller. I'm not just debating if it's going to be CW only or CW or SSB or either or, so I'm sort of thinking about that. Some thought about potentially having another look at the SDR radio. Some lessons learned there on noise, so sort of thinking about that. But any other ideas, please sing out. Another idea I had was a reduced parts count, so a really small parts count radio, to see how much or how little you can actually use it by way of components to have a usable SSB rig. So that was sort of an idea that came up. And at some stage I do want to, in terms of power amps, have a play around with the 510, the IRF 510, and potentially the 520, but I think some issues there with capacitance, but at least the 510. I bought a few of those from overseas, and I've had a few of them actually blow up, so I've got a sneaking suspicion they're duds, but I do want to actually have a sort of a closer look at how they work and ways and means to create power amplifiers using those. Anyway, I have rambled on way longer than I expected to, but that's not unusual. Any ideas and feedback, please sing out. Otherwise we will take our time, although I will take my time in building this radio up. I've got several work trips coming up in the next couple of months which will take me out of the office here, but in and around that we'll do some design work and start melting some solder and building some stuff. Anyway, so enough said. Please, any comments are always welcome, and we will see you for the build. Thanks so much guys and girls, 73s, and we'll talk to you soon.